All right, class. Wow, that's weak sauce right there. Anthony, come on. Come on. Expect better. I know it is. It is. He is a bad influence, so I'm glad you decided to keep a chair in between you guys today. See? Hey. Yeah. No one wants to hang out off the back here. All right. So, we're going to go over a mean value theorem to show that a car travels 110 miles in 2 hours must have a speed of 55 miles per hour at least once during this right here in the 2 hours. So, let's go ahead and first, what's the mean value theorem start with? Okay. Yep. Yep. And be at least one number C in the open interval B. Very good. All right. So right here, I have. So let's. I'm going to back up a slide or two to get. Here it is. Continuous, differentiable, and right here, for which the slope is equal to the derivative.
Sorry, real quick. So his calc is like messed up. Like it's not the same like G as the time.
It's not?
No, but it says 4.2 in the front. So I guess it was stapled correctly.
Oh, yeah. You should have 4.3 then.
Me?
That's 4.3.
Oh, yeah, sorry. 4.3.
You don't have 4.3. Maybe you were missing for those. Given the days you didn't show up. Are you traveling this week, Eva? Nope. Still no trouble.
For how long? Like a whole month almost?
Basically. Yeah, that's crazy. All right. Let me get back to there. So, let's find the slope. 2 hours, right? Okay. So it's basically f of 2 minus f of 0 and reading through this, the only information I have is this. What do we get? F of 2. Right there, I end up with 110 minus, what's f of 0?
0.
Over? 2. This is which line? This is my secant line. Secant line. So my slope is 55. So at least it goes there at least one time in between there. I don't have a function here. But I know that from here, if I start and driving, okay, we got Blade driving through that school zone, right? Okay. Is he going to start when he gets in his car? Is he automatically at 110 miles an hour? No, or I'm sorry, 55 miles an hour? So as soon as you sit there, it's already like bam, 55 miles an hour. Okay. Even in the Batmobile has to get up to speed. Not yours, but you got the Blade Mobile. Yes. Because it's a Malibu. Seriously, no, that was his car. He actually had like a Malibu Super Sport. Yeah. You haven't seen the movies?
Well, I've seen the movies, but
I'm telling you, he's got this classic car. It's freaking amazing. Anyway. All right. So here my secant line is already equal to this. So therefore it's already there. So this one was probably a little bit easier. But you had to look at it and find your values to get your slope of your secant line and showing that it's equal to whatever it is that they were asking for. So it must go at least 55 miles an hour at some point. So if I were to draw a line, so here's blade. So starting off, right here, he doesn't start off at 50 miles an hour. So he starts off right here at 0. So at some point, he's going to go, it's going to go faster than 55. And then he's going to slow down. He's got to go take a bathroom break. So he goes all the way down to 0 here, right? At that point, bathroom break. And then picks up speed again. In the 2 hours, he had to, fill up with gas, all that stuff. So he's back up to whatever speed he's going. So at least one time, because you start at 0 miles per hour, you have to go above 55 for some time.
Where's the secant line?
The secant line?
Yeah.
That's what I did by finding the slope.
No, but like in that graph you just did.
It's basically secant line is.
I can't really visualize it.
Okay, here's the secant line. So secant line is this right here. Because that's the average over the whole thing.
And this is the graph of like the F prime, right?
Yes. And so no, secant line is your average over the whole thing. And blade, being his driving is a little wavy going up and down. So this one would be the secant, because that's average all the way across. Like I said, when he gets in the car, he doesn't automatically start at 55 miles an hour. He starts at 0. And he's got to go above 55 miles an hour to make up that time so he can actually get to the place where he's going to in 2 hours. Does that make sense?
Yeah.
So for every time you stop, you have to speed back up. You have to go much faster than your 55 to get back on track to actually be there on a certain time frame. A little bit better? Okay. In words, f prime of x equals 0 for all numbers in a to b, then f is a constant function on the interval. So it's that constant which is at 55, right there. Bam, all the way across. Corollary. If a function is continuous on a closed interval from a to b, it is differential on an open interval from a to b, and f prime of x is equal to 0 for all numbers in x, open interval, then f is constant on a to b. So that answers your question with open, right, versus the closed. You're not including the ends. Okay, in words, if an object in rectilinear motion has velocity equals 0, then the object is at rest. Where Blade stopped to go poop. He was like prairie dogging it for like the last 20 minutes, and so he had to really stop right there. So yeah. So yeah, right. See right there. So that's where your velocity is equal to 0.
All right.
All right. Did I? No. Okay. Okay. Another one. If the function f and g are differentiable on an open interval from a to b, and f prime of x is equal to g prime of x for all numbers x in a to b, then there is a number c for which that f is equal to g of x plus c. So, what does it mean about these two lines? There's something key that you have to know about these two here. Go back to geometry. What would I say that these are? Here, let's see. Let's see. So, if this is true, what does that mean? Very good. Perfect. Right there. Good job. They're going to be parallel because if the derivatives are the same, that means they have the same slope. And then from there, they're going to be parallel. And then for them to not be the exact same function, there has to be a plus c somewhere in there to make them not collinear. That means the same line. Identify where functions increasing and decreasing. First derivative test. Now, I know you guys are taking super good notes on this because this is going to be key to a lot of what we're doing. Let f be a function that is differentiable on the open interval from a to b. F prime, if it's greater than 0 on a to b, then it's increasing. Okay, now what does that say? So f prime is my derivative, which gives me my slope. So if the slope is greater than 0, so in words, that's going to be the slope is positive. Thank you, that's what I'm looking for. The slope is positive, then it's increasing from a to b. Right here, if f prime of x is less than 0, or I would say that those are negative, right? Negative, then it's decreasing. So we're just going to make another line and actually show my slopes. That's the first derivative test. Determine open intervals in which that derivative, positive or negative, suppose that it's continuous on open interval and differentiable open interval. Right here, increasing closed interval, then is decreasing closed interval. First derivative test is valid if the interval is from negative infinity to b, or from a to infinity, or from negative infinity to infinity. Determine where the function right here is increasing and where it is decreasing. So, first thing I'm going to do is do what? Find the derivative. Let's find the derivative. So, f prime of x equals 6x squared minus 18x plus 12. And I'm going to look at that problem and say what? Yep, factor that. F that. So 0 equals 6 quantity x squared minus 3x plus 2. 6, what happens to that 6? Goes away. So I get 0 equals what are the factors of 2 that add up to be negative 3? Negative 1. Negative 2. So I can say that x is equal to 1, x is equal to 2. So I have key numbers here, critical numbers. So let's take a look. Draw your number line. Now, my function, f prime of x was 6 quantity x minus 1, right? that. Now, there's a reason why I'm using the factored form. When I'm evaluating, I really want to use a factored form because it makes my life a whole lot easier. All I have to do is plug in and multiply to see, is this going to be a positive or a negative? Okay, we pick numbers that is within the interval. So I'm going to start with 0. Plug in 0. So if I plug in 0, this is going to be -1. This is going to be -2. This is going to be 6. Okay, so is it positive or negative? That's all I need from there. I don't need the number, I need the value. I need to know if it's positive or negative. Yes.
How do we know if 0 is in the interval?
Just if this is a critical point, I could have picked any number to the left.
Why is it?
Is it continuous?
Yeah.
Is it continuous? Do I have an open interval here? It doesn't actually give me an interval, so it's over the whole thing, over the whole function.
So you could use any number.
Yeah, I'm going to use any number, but I want to pick numbers that are near that. I don't want big numbers. I don't want ridiculous numbers. I want things to plug in easy to actually show my math real quick. All right, so Blade, what number should I pick next? 3. Okay. All right, so if I do 3, it'd be 6 times 3 minus, that's 2, and that's 1. So that's going to give me, which is? Okay, but what am I looking for?
You're looking for whether it's increasing.
Okay, and so the word I'm looking for, if it's increasing, it is? Thank you. That's what I'm looking for again. So positive. So that means all this interval over here, so since there is no other changes, there is no more critical numbers outside of these, so it's not changing. So that means that from 2 all the way over to infinity is going to be positive. From 1 to the left all the way over is also going to be positive. Now, let's check. Negative what? I got to find something in this interval here. 1.5. 3 over 2. Okay, so that would give me a positive 1/2, and this would give me a negative 1/2, and this would give me, together? Yeah, give me a negative. So going back to the question, it says where it's increasing or decreasing. So this is increasing in my interval from negative infinity to 1, and it's increasing again at 2 to positive infinity, is decreasing at 1 to 2. Number lines. It's going to help you out for a lot of the stuff that you're going to be doing here. Because we're going to have not just first derivative tests, but we're going to have second derivative tests.
Why wouldn't there be a bracket?
Am I including those numbers? What is the slope at that point? What is the slope? Yes, very good. It's 0, right? If the slope is 0, is it increasing or decreasing? So 0 is neither positive nor negative, is it? So that's why it goes with parentheses, because it's increasing to that point right there. Yeah, it is going to be crossing, but remember, this is of the derivative, and the derivative gives me the slope. So that means right here the slope is 0. So let's go back to your driving, okay? So the derivative of the position gives you a velocity, right? So that's the same as f prime, right? Your velocity. What happens when your velocity is equal 0? You're not going anywhere, right? So you're at rest, and that's what this right here, this definition right here is. Where does it say? It says right here somewhere where it is.
I just wasn't thinking of it as velocity.
Yeah. So all this is velocity. It just depends on the type of problem that's given to you. We can give it to you in motion, where it's, position, velocity, acceleration. Or we could just go in derivative. So the original function, the first derivative, the second derivative, third derivative, if we need to go that. But yeah, it's the same thing. It's just how the information is given to you. We use it in different ways. But yeah. So it makes better sense to say velocity equals 0?
Yeah.
Okay, there we go. All right, so we're going to pick up this one here tomorrow. And everyone's going to make sure that they like, share, and subscribe, and they hit that notification button, especially if they slept through my class. Yeah.